In this video, we'll do 3 examples of factoring trinomials using the AC method. This method is intended for trinomials in standard form, ax squared plus bx plus c. So the a and the c that we're referring to are the coefficient in front of the x squared term and the constant at the end. So here's our first example, 2x squared plus 7x minus 15. Right, so I'll make an x to organize the information, and the first thing we do is multiply a and the c. Right, so 2 times negative 15 is negative 30. All right, and then the inner term, the 7x, that's the b is the coefficient there, and I'm going to write that at the bottom of the x. All right, and then what I'm doing is I'm looking for 2 numbers to go here and here, which could multiply to be negative 30, but which could add to be 7. Multiply to be negative 30, but add to be 7. All right, so I know that I need, because it's a negative 30, I know I'm going to need one positive number and one negative number, and then I just start looking for various combinations. All right, so you could think of, maybe you'll think of 10 and 3 for 30. All right, and maybe you don't initially think of that one. Maybe you think of 15 and 2, 1 and 30. All right, and then notice that since one's positive and one's negative, when we add those, essentially what we're doing is subtracting. All right, so if I looked at these numbers, 10 and 3, 15 and 2, 1 and 30, which of those could I subtract to get 7? And the answer is the 10 and the 3. All right, so a positive 10 and a negative 3 will add together to get 7, or 10 minus 3 is 7. Okay, so next what we need to do is to rewrite our trinomial. And I'm going to write this as 2x squared, I'll leave a big space, last term negative 15, and then I want to use the numbers that I've just found to rewrite the middle term. So I could rewrite 7x as a 10x minus 3x. All right, now here's the grouping part. I'm going to group the first 2 terms, group the second 2 terms, and then I don't want to change this problem and multiply. I'm just using the parentheses to show grouping, not multiplying. So I put a plus sign in the middle to show that. All right, and now what I'm doing is looking for the greatest common factor that I could take out of each of these 2 parentheses. All right, so for the first one, for 2x squared plus 10x, notice that you can factor out an x from each of those, and you can also factor out a 2. So if I do that, I'm dividing each by 2x, and in the first term that leaves me with an x, and when I divide 10x by 2x, that leaves me with 5. And you can check this just by distributing. Think about what would happen if you distributed 2x times x and 2x times 5, and make sure that that does still equal 2x squared plus 10x. All right, and then in the second parentheses, I'm doing the same thing, looking for the greatest common factor of negative 3x and negative 15. And if you have a negative that you could take out of each of these, let's go ahead and do that. All right, so I'll factor out a negative, and then it looks like that the greatest common factor of these would be a 3. Okay, so dividing each by negative 3, negative 3x divided by negative 3 is x, and negative 15 divided by negative 3 is positive 5. Right, now our goal here, if you do this correctly, we're trying to get 2 parentheses that match. And the reason we want those is because now we have 2 terms being added, and x plus 5 is a factor in each of those terms. So now what I can do is actually factor out the x plus 5. Okay, so I'm using the distributive property. I'm kind of undistributing here. I'm factoring that out of each of those 2 terms, the orange boxes, and then seeing what's left. Okay, so when I take an x plus 5 out of the first box, that leaves me with a 2x. And when I factor it out of the second box, that leaves me with plus negative 3 or minus 3. And there you have it. Those are 2 binomials, 2x minus 3 and x plus 5. So we have factored 2x squared plus 7x minus 15. Okay, and you can check this, just use FOIL or the distributive property to make sure that this does equal the original problem. All right, here's a second example, 10x squared minus 11x minus 6. So I'll start with an x, and multiplying a and c. Okay, 10 times negative 6 is negative 60. And then at the bottom, I'll put the middle coefficient, negative 11. So I'm looking for two things which multiply to be negative 60, so I need one plus and one minus. And then because those numbers are going to be opposite signs, I'm really looking for two numbers that will subtract to give me a negative 11. So I'll start thinking of factors of 60, and I could think of 20 and 3, 60 and 1, 30 and 2. And if you start looking at these, none of these will subtract to give you 11 or negative 11, so you need to keep thinking. All right, and hopefully eventually you'll stumble on 15 and 4. Now 15 minus 4 does not give negative 11, but 4 minus 15 does. So if I make this a positive 4 and a negative 15, that still multiplies to be negative 60, but now when I add 4 and negative 15, I do get negative 11. So that's the combination that I want. Okay, step 2, once you've found those numbers, you want to rewrite the quadratic expression. So here's the first term, and the last term we leave unchanged, and it's this negative 11x that we want to rewrite. So I'm going to rewrite that as negative 15x plus 4x. And there's no set order. You could write this 4x minus 15x. Either one is correct. It'll look a little different in the middle steps, but you'll still end up with the same final answer. All right, next I'll use parentheses. I want to group the first two terms and group the second two terms. And notice this time I had a plus sign in the middle, so I'm just kind of leaving that there. If you have a negative, you would want to group that in the parentheses. Okay, and then I'm looking for the greatest common factor of each parentheses. So in the first one, I can take out a 5 and also an x. Right, so 10x squared divided by 5x gives me 2x minus, and then 15x factoring out of 5x leaves us with a 3. So at this point I can kind of anticipate what my next parentheses should be. I'd like to get it to be a 2x minus 3 so that I have a common factor that I could take out of each of these two large terms. So what I'm going to do next, I am trying to find the greatest common factor of 4x minus 6, but hopefully I already know what the answer in parentheses should be. So I'm trying to get a 2x minus 3, and I would be looking to see what I could factor out to get that, and it looks like a 2 will do the trick. Okay, so 4x factoring out a 2 gives me 2x, and negative 6 factoring out a 2 gives us negative 3. Alright, so now you have two large terms, this product and this product, and 2x minus 3 is a common factor in each, so I can use the distributive property to factor that out. And then I would see what's left, and I have a 5x and a 2. Okay, and then that's factored. All right, and again, you can check this. Just multiply 5x plus 2 times 2x minus 3 and see if that does equal the original problem. All right, here's one more example, and this one has definitely some larger coefficients. So we kind of skipped this step in the last two, but one thing you should always do is see if there's any way you can make this problem simpler to begin with. So if there was a greatest common factor that I could take out of all three of these terms, that should always be my first step. So the first thing I would want to do is probably factor out a negative, just so I don't have a negative first term. And you might initially notice that each of these can be divided by 100. And then maybe you might also notice that they're even hundreds, so we could also take out a 200. So let's try that and see what that leaves us. So factoring out negative 200, that leaves us with 4x squared. Okay, factoring out a negative, this is going to change to a plus sign. All right, and that'll leave me with plus 4x. And then a plus divided by a negative is going to leave a negative, and 600 divided by 200 is 3. All right, you can check this, see if when you distribute negative 200 to these three terms, make sure you still get the original problem. All right, so I can take out the negative 200, but then to deal with the rest of this problem, I'm going to use that same AC method. Okay, so A times C, 4 times negative 3 is negative 12, and then my inner term is a 4. So I need two numbers that multiply to be negative 12, so 1 plus, 1 minus, and that add to be positive 4. All right, so factors of 12, 1 and 12, 2 and 6, 3 and 4, and it looks like 2 and 6 are 4 apart. 12 and 1, I could combine those to get either 11 or negative 11, and I don't want that. And 3 and 4 would combine to get either 1 or negative 1, depending on which one you make a negative. All right, so it looks like I want a 2 and a 6, and if I'm going to need a positive 4, then I need a positive 6 minus 2 to get that 4. All right, so I will rewrite this trinomial, 4x squared. The middle term, the 4x, I'm going to rewrite as plus 6x minus 2x, and then the last term leave as negative 3. Okay, so now I'll group, and let me just put a giant bracket around this so I can make it clear that negative 200 is multiplied times everything inside. Okay, so I have two groups. 4x squared plus 6x, negative 2x minus 3, and I'll put a plus sign in the middle because I don't want to multiply those, I'm just grouping. Okay, next I'll factor out the greatest common factor. Okay, so out of the first parentheses, 4x squared and 6x both can be divided by a 2 and also by an x. So 4x squared divided by 2x is 2x, and 6x divided by 2x is positive 3. All right, now the second parentheses, I'm just trying to get this to be a 2x plus 3. So it looks like the only thing I need to factor out here would be a negative sign. I like the numbers, I just don't like the negative. So let me factor out a negative 1. And notice you can check, distribute, negative 1 times 2x is negative 2x, and negative 1 times 3 is negative 3. So that does work. All right, so now I have two terms, this term and this term, and 2x plus 3 is a factor in both. Okay, so I can factor out a 2x plus 3 and see what's left. And what's left is a 2x plus a negative 1, so 2x minus 1. All right, so this one actually factors to 3 terms, and I can get rid of the brackets now if I wanted to. Okay, because all 3 are being multiplied. So I just have that extra monomial in front, the negative 200, because I had a greatest common factor at the beginning that I could factor out. And that's it. All right, so this is fully factored. I can't factor that anymore. I know that because I am down to what we would call linear terms. So things that just have an x in them, there's no more x squared. And that is the AC method.